we've already seen that if you're given the position r of t, then if we want to find the velocity of a motion, you take the derivative, and you get v. And then if you want to find the acceleration of that motion, you take another derivative of v, and you get a acceleration. Let's say we want to reverse this procedure. Well, since going in the forward direction means taking derivatives, going in the opposite direction means doing integrations. So if we have the acceleration as a function of t, then to find the velocity, you do an integral, and it turns out to be the most convenient way is to do it as a definite integral. And then if you want to find position, you integrate up again. So here t0 is some fixed time at which you have to know either the velocity or the position, depending on what you're finding. Because as always, when you do an integral, you get a constant of integration. And you have to determine that constant by knowing something at one instant in time. So we have that at our disposal. And then Newton's law, or Newton's second law of motion, actually, states that force is mass times acceleration in the vector sense. So F is the net force on an object, m is the mass, and a is the net acceleration. So this is the proper vector statement of Newton's law. And just keep in mind that F and a need not be constant for this to work. In fact, if you're given the force, then you can turn that into an acceleration, and then you can integrate to find position and integrate again to find, or I'm sorry, you can integrate acceleration to find velocity, and then integrate again to find position. Now there is a special case where the only force present is gravity, or due to gravity. And let's say that takes place in the xy plane. So this is often used to model the motion of a projectile, like a cannonball. And in this case, the force is constant, and it only has one non-zero component, where g is about 9.8 meters per second squared. So in a problem where you have motion due to gravity only, or with gravity supplying the only force, then you start with this is your acceleration, 0, negative g, and from there you can find velocity and position.